Okay, so the last piece here is to discuss the relationship between Ka and Kb values. So remember that Ka is a weak acid equilibrium. Kb is a base equilibrium. Now, if you're dealing with a conjugate acid-base pair, there is a relationship of how they are interconnected. So if you recall, we looked at the Kw in our last lesson. So Kw is a constant, of course, this is all at SATP that we're discussing. So the Ka multiplied by the Kb of the conjugate acid-base pairings is equal to Kw. Now the reason why I said SATP is because this number for Kw will change depending on the temperature. So technically this relationship is true always at the same temperature of the reactions. However, the Kw of 1 times 10 to the negative 14 is only true at SATP. So if it's happening at a different temperature, and you would have to, if you have to use this relationship, the Kw will have to either be given or a chart that you have to look up for it or something, but you can't use this number unless it's assumed at SATP. Okay, so why are we talking about this? Because when you're coming across different questions, you may have a Ka value for an acid, but maybe you're dealing with a base equilibrium. Okay, so if you're dealing with a base equilibrium and you don't have that value, you will have perhaps the conjugate that you can actually look up. I'll give you an example. So let's say we're dealing with a weak base equilibrium with fluorine, for example. Right, so if this is a base, right, it's going to become HF plus hydroxide, AQ. So technically, the Kb, so remember that whether it's an acid or base equilibrium really depends on what is reacting with water. So in this case, my fluorine ions are doing the accepting. So this is a base equilibrium, which would be HF times hydroxide over fluorine. So let's say I'm trying to look up in my chart. I go to the back of the textbook and there's no Kb value listed for fluorine. Well, like, how am I going to do this question if I don't have Kb? Let's say you're trying to solve for X here in a nice table. However, you can look up the Ka of its conjugate. So remember that conjugates, if we looked at this in the last lesson here, are essentially the before and after kind of snapshots of a species. So here we have fluorine ions before the reaction has begun. And then afterwards, after it has accepted a hydrogen ion, it's now hydrofluoric acid. So fluorine ions are a base. HF is an acid. So this is an acid-base conjugate pairing because they're the before and after hydrolysis. So we can solve for the Kb of this by doing Ka times Kb is equal to Kw. So the Ka would be the HF value. The Kb would be for the base of its pairing, right? The acid-base pairing. This is also why Kw is equal to, if you look at the conjugates of this, hydronium and hydroxide together are equal to Kw. But anyways, that's not really helpful for what you have to use this for in this section. Okay, so it's mostly, when are you going to be using this? It's when you're dealing with an acid or a base that you're not able to look up, but you have its conjugate value. Or the question might give you the K value for one, but the question is for the other, like, right? So if this is dealing with a base equilibrium, but you have the acid Ka value, you can still use that to help you continue on and solve for that. But the important thing to keep in mind is this is only for conjugate acid-base pairings. So you can't just randomly pick any acid and any base and multiply them to get Kw. They have to be a pair up. Okay, so let's take a look at this. So what is the Ka for the conjugate acid of aniline, which is a weak base? So the Kb value is this. So we have a weak base, and we want to know what the Ka value would be for the conjugate acid of this weak base. So this is very simple, just rearranging the formula. So Ka times Kb is equal to Kw. If we plug this value in for our Kb, we get our Ka value after we, of course, this is 1.0 times 10 to the negative 14 here, right? 2.5 times 10 to the negative 5. So when you are stuck and you don't have that value, you are always given enough information to solve the problem. Just keep that relationship in mind when going forward with this.